Electronics 101. What is the difference between voltage and current? To start, we need to define them first. Current is the number of electrons passing a given point in 1 second, and it is measured in amperes, while voltage is the difference in electrical potential energy per unit of charge between 2 points, and it is measured in volts. To explain it in the simplest way possible, just think of a water tank with a pump that pumps water up to an elevated tank. The elevated tank has a lot of potential energy that can do work, but it has not yet released this energy. To release the energy, we can connect another pipe to the tank to produce a flow of water, which we can call the current. In this example, the total stored potential energy of water in the elevated tank can be thought of as the voltage. If we make the pipe larger, the voltage remains the same, while the current increases. However, if we remove the second pipe, there will no longer be any current, but the voltage will remain the same. Similarly, a battery has a voltage associated with it, even if it is not yet connected to a circuit or doing any work. If you remember the earlier definition of voltage, we learned that voltage is the difference in electrical potential energy per unit of charge between 2 points. In the case of the water tank, when we talk about potential energy, we are referring to the force of gravity that pulls the water from point A to point B. The potential energy, which we can also call voltage, will increase if we increase the difference between the 2 points. It is important to remember that voltage is always in reference to a difference between 2 points, even when we're talking about a 9-volt battery, where the voltage difference is 9 volts between the two terminals. If we apply this concept to electricity, where the applied force is the electromagnetic force, we can think of it as the repulsive or attractive force between electrically charged particles. In electromagnetism, like charges repel each other, while opposite charges attract each other. In this example, we have a conductive wire with 1.5 volts battery. We will put the battery in the conductive wire to complete the circuit. Now, the electrons from the negative side of the battery will be attracted to the positive side of the battery with a force that is equal to a 1.5 volts in this example. Without voltage, the electrons will move randomly in all directions. Thus, voltage is what pushes the electrons around the circuit. To sum it up, current is simply a measurement of the flow of electrons passing through a certain point, and voltage is the electrical potential difference between 2 points. It is the force that makes electrons move in a certain direction within the circuit. If you have no electronics component yet, you can visit the PET simulation website and try to experiment with the power source there. And as always, keep learning and have fun. Bye!